Welcome everybody. I have a pretty long word problem here, and I'm going to just tell you that a lot of this information that's on here is really not helpful to us in order to figure out this problem. But this is how we paint the picture. So I'm going to read through it, and I'm going to focus on the parts that are really important through it. So we have the snakehead fish, which is a predatory species with a natural habitat found in the waters of Africa and Asia. Environmentalists recently found with sports fishermen in the United States, they've become concerned with the discovering of snakehead fish that have been introduced into the American waters. And these were known as invasive species of fish because they have no natural predators, and they can survive up on land for up to 4 days, and they can travel distances to 1/4 of a mile across wetlands. In addition to the reproduction rate of the snakehead, which is extremely high, allowing them to completely take over bodies of water, wiping them whole populations of species of fish. Well, we're already down to here, and still nothing mathematically to tell us about this problem. So now we get to this point. The snakehead fish will double. There's the point I need. It's doubling its population yearly. And then currently the Fish and Game Commission estimates that there are about 100 snakefish living in the Schuylkill River. All right, now that I have those two pieces of information out of that huge long paragraph, we're gonna find out an equation, a table, fill it out, get a graph done, and figure out some parameters for this equation. So I have this filled out already. As you can see, we have our Y values up here on the population of the fish, our years on the bottom. We've scaled this by 6-month increments on the bottom here. These numbers are gonna get big really quickly. So we're just gonna go with this. And then you can see I just did this. So again, 0, 0 down here. And we're gonna start off with what's gonna happen. So in year 1, we'll start there. What happens with year 1 is we're starting off with what the population is, which you're told in here. Again, very last sentence, there were 100 snakefish. So we're gonna start off with a population of 100. And then the other piece that you see up here on here, it says is doubling yearly. So after year 1, this 100 snakefish now doubles to 200. And then it's gonna double again, leaving me with 400. And then it's gonna double again the following year, and that's gonna be 800. And then by the 4th year, it's gonna double and be 1,600. So there's the table all filled out. As you can see, pretty substantial numbers at this point in just a few years. Now when we're looking at writing the equation for this, we're just simply going to go ahead and think about what we started with. So we're going to start off with f of x, and we're going to do equal, and then we're going to start with what our value is that we began with at 0 years, which is 100. And then we were told that these double. So we're going to times this by our growth rate, which is 2, because it's doubling. And then we have to the x exponent. So that is my equation. So now when I'm looking at this and I'm trying to figure out my values, we have our x value, which is the x-axis, which is our years. So that is going to be my parameter for that. So this is the year, or years. Now my y, which can be also written as f of x, put that there so you can see this is the nice functional way of writing it, function notation. And so my y value, as we know, is the population of the fish right there. So this is the fish population. And then a couple of other quick things just to write is what's happening in this problem. So what do those numbers represent? So the 100 that we talked about is our start value of population. So it's the number of fish at year 0. And then we have our growth factor, 0 years. And then we have 2, which is the population that is doubling. So that is the doubling of fish. And so this will give me an example. And then I'm just going to do my plotting. So we're going to go ahead with, this is 200 right here. So halfway up would be 100. And that's at year 0. And then we're just going to go ahead and graph the rest of our points. So 1 year, it's 200. So we'll start right here. And then we're going to go with year 2, which is 400. And let's see if you can see this. So as you can see that, I'm going to just pull this up a little bit further up so you can see it. At year 3, we are up to 800. By year 4, we're at 1600, and then we're going to be off this graph. Oops, I did this wrong. It should be there, and then this should be at 1600. I canceled this out. That's not there. So we're going to go ahead, and then this is going to continuously go up, and then it will be off the graph in the next point. So this is what we've got, and that would continue growing and growing, and that would be my graph. So if you want more questions like these, you can find these in my YouTube channel, YouWantAlgebra. These can all be found in my exponential functions graph, and you can locate everything on Instagram, YouTube, and TikTok at YouWantAlgebra. Again, playlist is exponential functions, and make sure you like, share, follow for more.